All right, so I'm just kind of going over and doing some tests with my batteries that we're building here, and just doing a series connection. So this is just 4 in series, 4 independent cells in series. You can see we got positive, and then a series connection to the next one, series connection to the next one, and the next one, and we got the negative out. So this would be like a 12-volt setup. Some do 4, some do 3S, but what we got here is 16 because we're fully charged. And when I put a load on these, because what these, and I've done this, I've showed you in some other videos, but we got independent BMSs on each cell. So they're like cell level fused at 4 amps each. So what happens when I exceed 4 amps? That's kind of the question here. So we'll crank it up. We'll ride 3 for a second. We'll go above it. Holding above it for a second. See if it'll give. Yeah, we're gonna go up a little bit. Man, just barely turning it. So what do we got here? Now when we take the load back off, you'll see it rises back to 11 volts. So what happened is, you could feel even a little warmth out of them, but what happened is one BMS tripped. Obviously, they're not all going to trip at once. So one BMS tripped, and now when we take the load back off, even if we were to take the load back off, put it on, see what we get here. We're still at 11. So you'd think, well, okay, so let's apply the full voltage to this, and maybe that'll wake that BMS back up. And so it's what we got here. We got our power supply set at 16 volts. And so if we put 16 volts on here, nothing. So we just put it on and took it back off and dropped right back to 11 volts. So what happens is the one is tripped, and now we got to wake that one up. So I don't know if with a full pack BMS, if that BMS will attempt to try to wake it up. When you charge, you know, so see what we're gonna do here. Last time, I'm gonna assume it's the same BMS that tripped. It's the last time that I did this, so we're gonna try to put that on here. Just apply 5 volts to one cell, and it will wake it all back up. So as soon as we touch the positive lead to that cell, it'll wake the whole pack back up, just as easy as that. So we get the whole pack back, and we can load it up again, and just for kicks and giggles, we can trip it again. And so, it's not like we can even draw anything. We can't even draw anything out of it at that voltage. So it's kind of odd. So I don't know, maybe if we put a BMS on here and you apply a charge to the whole pack, if that BMS will try to wake that one cell up through balancing, dumping one from one to the other, or an active balancer or something. So I'm not quite sure how to overcome that, other than over engineering the amp draw, or basically buying a BMS that trips, a full pack BMS that trips at close to that 3 amp range, or maybe even the 2 amp range per cell. So in this sense, if we were to take two of these, for instance, parallel them together, we'd be able to pull 8 amps off of this pack. But if I just kept the BMS, so the BMS tripped at 4 amps, and it never got close to the cell level tripping, then that's an option. So just something kind of trying to troubleshoot and come up with. One thing I have found is when I paralleled all 4 of these, they work, it's almost like they work a lot better paralleled together. And I was able to get 4 of these to go up to about 20 amps, which puts, you know, all of these working together, that puts it over 4 amps each. So maybe they're a little more than 4 amps that they trip at, but I was kind of able to ride the 20 amps for a while. So it'd be like 16 amps would be 4 times 4 would be 16. So I was able to go 4 amps beyond that, which is kind of interesting. But anyways, I figured I'd kind of share some of my testing of these batteries just in case you happen to be planning on buying some of these from Battery Hookup. Hope you enjoy the video.